In this three-part video series, we're going to talk about the binomial distribution. In this first video, we're going to introduce the notion of a binomial experiment. Now, to classify an experiment as binomial, there has to be three criteria that are satisfied. The first one is that we have to have a fixed number of identical trials. So we predetermine, before we start the experiment, how many trials we're going to do, and we can't change that once we start. And each trial is identical, which means they're performed under identical circumstances. The second criteria is that each trial can result in one of two ways, and we usually label that as success or failure. The third criteria is that trials are independent of one another, which means the result of the first trial will not impact the result of the second trial, and so forth. The probability of success, which is usually denoted by lowercase p, is fixed. So these three criteria must be satisfied for an experiment to be classified as binomial. Let's take a look at a simple example. Toss 5 coins, record the result, and we want to look at the number of heads. That's the quantity we're interested in. So let's go ahead and toss 5 coins and look at the results. So here it turns out we got heads for the first trial, tails for the second, tails for the third, heads for the fourth, and tails for the fifth. Since we're interested in a number of heads, that gives us a simple way of labeling which result is a success and which one isn't. So naturally, H will be labeled as success because that's the number we're interested in, number of heads. So let's summarize here. Here we have 5 trials. Each trial can be one of 2 possible outcomes, and we have a clear way of labeling that. And the probability of success is 1/2, and that doesn't change from one trial to the next. So the result of the first coin is not going to impact the result of the second coin, so the trials are independent. So this experiment satisfies all the criteria and can be classified as a binomial experiment. Here's another example. We're going to choose 5 marbles, one after the other, and with replacement. What that means is we choose a marble, look at what it is, put it back in the bag, and then take another one. Now this bag has 6 red and 4 green marbles, okay? And we're interested in the number of red marbles. So let's go ahead and perform this experiment, see what happens. Okay, great. So the first bag resulted in red, or green, the second one in red, the third one in red, the fourth one in green, and the last one in red. So we can label that, and there is a simple way of labeling. Okay, all the red ones will be success because that's the number we're interested in. It's the number of red marbles. Okay. Now, since we're replacing the marble after choosing it, before each trial, we always have 6 red and 4 green marbles. And so the probability of success, which is 6/10 or 0.6, is not going to change from one trial to the next. And since we're starting out always with 6 red and 4 green before each trial, what we get after the first trial is not going to impact what happens in the second trial. Now in both of these examples, you saw that we're interested in the number of something. For the previous one, it was the number of heads, and the second one was the number of red. And that gave us an idea of how to classify success. So let's formalize this and let's talk about something called the binomial random variable. Now, a random variable is a number, okay? And it's a random number because it depends on a random process. The binomial random variable is specifically the number of successes, usually denoted by capital X, of a binomial experiment. Okay? So whatever success is for your experiment, the number of successes is the random variable. Now, lowercase x will usually tell us all the values that a binomial random variable can take. And that's always going to be 0, 1, 2, etc., where n is the number of trials. So in the experiments that we looked at, in the first experiment, we were tossing 5 coins. So we label capital X as the number of heads because that's the quantity we're interested in. Since success is labeled as heads, then the random variable is number of heads. The values of X are always from 0, 1, etc., all the way to the number of trials, to 5. The other experiment we looked at, choose 5 marbles, one after the other, and so forth. Again, we had 5 trials. In this one, the number of success was labeled as R, so the random variable, which is number of successes, we're just going to say is number of reds. And again, the values of X are from 0 through 5. In the next video, we're going to perform some simulations and repeat these experiments many times and try to understand what the distribution of the random variable is.